All right, a mid-segment of a triangle is a segment that joins the midpoints of two sides. That's it. Super easy. So how many mid-segments are in a triangle? 3. So what do we call point X here? Well, point X is the middle of QP. So what do we call the middle of something? The midpoint. Yeah, so that's a midpoint. And then Y is also a midpoint. And then so is Z. They're all midpoints because they're all right in the middle of their segments. So a line that connects a midpoint to a midpoint is called a mid-segment. So there's 3 of them. And what do you notice? What does it create? Creates another triangle. And that is called the mid-segment triangle. Have you ever seen those diagrams where it looks like the triangle's like kind of like spinning inside of itself? Well, you could actually do this again. You could do the midpoint of the mid-segment triangle to the midpoint, to the midpoint, to the midpoint, and then midpoint to midpoint to midpoint, and then midpoint to midpoint to midpoint. And it just keeps kind of going inside of itself. So you can do it lots of times. Oh, that's all weird. All right. And then there's 2 things that are really important about a mid-segment. So here, D to E is midpoint to midpoint. So that is one mid-segment. So we have side AC and we have mid-segment DE. And what are some things that seem to be true? Like if you had to take a guess, it's probably true. What does it look like? The blue segment compared to the red segment. Try not to look at this. Good guess. Sean, what do you think?
That segment DE and segment AC are parallel.
Perfect. They are. That's exactly correct. They are parallel. And there's one more thing that happens. So that's the parallel. They are parallel. And then, what is this saying? DE is half of AC. Literally, if I were to write this out in an English sentence, I'd say DE is half of AC. So let's say AC was 8. What would DE be? 4. Super easy. Okay? So that's the mid-segment. So let's take a look at this example here. 3n plus 12 equals n plus 14. I'm going to do something wrong, and I want you to tell me why it's wrong. Oh my gosh. Look at that real quick. See what I wrote. Don't write it down. Because every test from years past, there's always students that do that. And what's wrong with that? Piper? They're not equal. Does that segment look like it's the same size as that segment? No, an equal sign means they're the same. But we do know something about them. How many of these would it take to fill this? 2 of them. So what we need to do is we need to multiply n plus 14 times 2. Go ahead and write that down. Not hard, but it's something you have to remember. It would take 2 n plus 14s to be as big as 3n plus 12, right? Bless you. If this is half as big as this, that means it would take 2 of these to fit. And you can kind of see it, right? If I drew a line over and made a rectangle, it would take 1 of them, and then it would take 2 of them. So it takes 2 mid-segments to equal the outside side. Yeah, Abby? Now solve that real quick on your own. Parker, what did you do first? Distribute. Good. So we get 2n plus, what does that come out to? 28. So we distribute, a little distribution property, just like on our proofs. Okay, Cole, what would you do next?
Subtract 2 from the
Good. That's probably what I would have done as well. Because how many n's do we have on the left side now? Just 1 n. And I'm going to go ahead and subtract this over. 28 minus 12 is 16. That is the final answer because it just asked us to find n. How could we check our work? It would be pretty easy. How could we check our work and see if this is correct? Boston, what do you think? Yeah, plug it back in. So if I take n is 16 and I plug it into here, what is 16 plus 14? 30, right? So this little mid-segment is 30. Now, just because we know what should happen, what should this be? It should be double the size. So now if we take 16 and we plug it back into here, it's 3 times 16 plus 12 more, 60. Good. So it does work. That is correct. Down here it says these are mid-segments. What is the perimeter? What's perimeter mean? You guys remember from middle school? What is perimeter of something? What about the outside? Yeah, the measure of all of the outside edges added up. So add up all sides. Perimeter means add up all the sides. And we need to find the perimeter of x, y, z. So x, y, z, we would call the mid-segment triangle. So on a test, I could say, what's the perimeter of the mid-segment triangle? So let's figure out something. Obviously, this is 3, so that's good to go. We're done with that. Now, if this is 4, what is the other half of, what is YW? 4. So VW altogether would be 8, right? But now if we look at the side that it looks like it's parallel to, so if this is 8, what is the side that looks like it's parallel to? Half of it, it would be 4. And then lastly, if this whole side is 9, I'll use a different color here. If this side is 9, what is the parallel mid-segment measurement? 4.5. Those are the 3 sides of the mid-segment triangle. So now we just need to add them up. So 4 plus 3 plus 4.5 equals 11.5. That's the perimeter of the small triangle. We could also pretty easily find the perimeter of the big triangle, the original triangle, because obviously we know this is 8, we know this is 9. How could we figure out the length from V to U? Jack? Boston?
The opposite side on the, I don't know, but
The mid-segment
yeah, I don't know. Yeah, the mid-segment is 3.
is 3, so what is the side that it's parallel to? 6. So this would be 6. Good. Can we figure out the perimeter now? Yeah, 8 plus 6 plus 9. Good. Let's just take a second and fill this out. We have a new segment called a median. And a median is a segment whose endpoints are a vertex of the triangle, and the opposite midpoint. So label those things on your picture real quick. D is a midpoint again. How is this different from a mid-segment? How is a median different from a mid-segment? Boston, what do you think?
It's in the middle of the triangle, not just the one mid-segment.
Yeah, close. A midpoint or a mid-segment goes from a midpoint to a mid-segment, the one we just did. Midpoint to a midpoint. So that's easy to remember. The mid-segment goes from the midpoint to the midpoint. All the mids. Mid. The median goes from a midpoint to the opposite vertex. Now you have to be careful. Does it look like C is bisected? Does this look like it's the same as this? No, so it kind of looks like an angle bisector, but it's not, so be careful. A median is different than an angle bisector. So if I took an angle bisector, that means you're literally cutting the angle in half, which would probably look a little bit more like this. So that would be an angle bisector. And does an angle bisector go to the opposite midpoint? No. Not necessarily. So be careful. The place where they end is not necessarily the same. All right. And this is the coolest thing that this does, is it creates the centroid. And what the centroid is, very important to underline this, the center of gravity. I know these notes are kind of long, it's just a lot of pictures. Okay. Here's a definition there on your notes. Concurrent is where two or more lines or segments intersect. It's at the bottom of the previous page. I skipped past it. Concurrent, I'll give you a second to write that down, is where two or more lines or... So median goes from the midpoint to the opposite vertex. Midpoint to the opposite vertex. Midpoint to the opposite vertex. And what do you notice about all three medians? Yeah, they intersect. They are concurrent at point P. That means all three lines intersect at point P. And P is the centroid, which we call the center of gravity. And it literally is the center of gravity. So probably next class, we're actually going to find the centroid and try and balance our triangles. Because it should, if you do it correctly and you do a really good job of it, it should balance on like a cone or a point. And we have another important relationship with our centroids. I like to call it the 1/3, 2/3 theorem. So it's called the centroid theorem. But if you take a look at it, it really looks like it. So look at segment AY. The centroid splits that segment into 1/3 and 2/3. So can you see how it kind of looks like it? Like this looks like it's 1 of 3 and this looks like it's 2 of 3. So let's say PY is 4. P to Y is 4. How far would it be from A to P? 8. So 4 to 8 is a 1/3 to 2/3 relationship ratio. So A to P would be 8, and obviously PY is 4. So let's take a look at this picture here. Let's fill out all of the missing values. So starting off, A all the way to E. Let's split this into thirds because it's our 1/3, 2/3 theorem. If this is 6, what is 1/3 of that? Or I should say, what is 1/2 of that? It would be 3, right? So 3 and 3, that's 2 of the 3 segments across the triangle. So CE would also be 3. So what is the whole thing? 9. So obviously CE was 3. Okay, next we have, it says find BD. So BD is down here. How could I find BD? All right, let's go down a little bit. That's a 9. What would BD have to be? This is your clue. 4.5. So that's B is a midpoint. A median goes from a midpoint to the opposite angle. So if B is the midpoint, half of 9 would be 4.5. Okay, the next one, it's asking me to find the distance from F all the way to D.